Hi, everybody. Now we're doing problem number six. Here's a word problem. This is section 1.1. This is a word problem. Airplane speed. So two planes start from Los Angeles International Airport, which I think it's referred to in the parlance as LAX. I think that's what they call that particular airport, if I'm not mistaken. Anyway, these two planes start from Los Angeles International Airport and fly in opposite directions. So they're flying away from each other. Uh, and the second plane starts 1/2 hour after the first plane, but its speed is 80 kilometers per hour faster. So the second plane gets a late start, but it reminds me of the hare and the tortoise. So the slow poke starts first, then a half hour later the fast poke starts second. Um, and he's going 80 kilometers per hour faster. Um, find the airspeed of each plane if, so we need a little more information here, if 2 hours after the first plane departs, the planes are 3,200 kilometers apart. So we have, this is what they call a word problem. And let's analyze this a little bit. Let me see now. Well, first of all, let me just draw a picture, just because I like drawing pictures. So let's see. Let me stop the share. All right. So the two planes, they're starting here. Okay. So basically, we're going to add up their distances, and we know. I think we all learned that distance equals rate times. You guys all know that. And time is not really a variable. They give us a time. They say one is one, they say it's 2 hours. Well, the first plane is going to be flying for a total of 2 hours. The second plane is going to be flying for a total of an hour and a half because it got a 30-minute, delayed start. So we also know that the second plane is faster, 80 miles faster. So here's my two equations. Obviously, R1 is the rate of the first plane, R2 is the rate of the second plane. I think that's self-explanatory. So negative R1 plus R2 is equal to 80 because, right, because right, because the difference between the two planes is 80. I also know that the distance adds up to a total of 3,200. So what's the distance to the first is, it's rate times time. Times whatever the rate of the plane is. I'm sorry. Sorry. I messed that up already. You see that's a two. Okay. And the second plane is going for three halves, an hour and a half. And this is the first distance, that's D1, that's two. And I'm just saying that I'm just telling that D1. I'm not introducing new variables. I'm just saying this is the first, that's the second distance. Let me rewrite the whole thing a little bit neater and nicer. Um, negative R1 plus R2 equals 80, and 2R1 plus three. Now I don't care if you write 1.5 or if you write three. I don't know. I'm writing three halves. I don't know why. So these are the two distances, and that's 3,200. So I'm going to, and here's my two equations. So I'm going to again. I want to cancel out that lower left corner. So I'm going to add. I'm going to add two times equation one plus equation two, and that's going to become my new equation two. So two times negative R1, that's just going to cancel out. So I have my top equation is negative R1 plus R2 equals 80. And my second equation, when I add twice, uh, when I add two of the 3,200, that's at 160, that's 336, that's 3360. here's my now my new equations. If I want to be true to form, I'm not so obsessed with this. If I want to be true to form, I would multiply the top equation by -1. I don't think it matters that much, but I'm going to do it just to be cool. Like negative equation one is going to become the new equation one. So I now have, because there is this thing of whatever. Anyway, we're over here. So R1 minus R2 equals -80. And I'm also going to multiply I should have left more space over here. Sorry about that. I'm also going to multiply 2/7 times R2. That's going to become my new R2. So I multiply this by 2/7. I get just here. I just get a plain R2, plain R2. And what's 2/7 of this? What's 30? Let's see, 33. I'm gonna have to do some manual labor now. Uh, let's see. 3360 divided by 7. 3360 divided by 7. That's 28. That's 4. And subtract. That's that's 556. It's 8. 5, 6. We're done. So 0 there. So R2 is equal to, but I have to multiply by 2. So 2 times that is 960. Okay, so R2 is equal to 960. Now I back substitute. When I put 960 here, I get R1 minus 960 equals -80. So I add 960 to each side, and I get R1 equals 880. So my two speeds are R2 is 960. So the first plane is going at 880 kilometers per hour. The second plane is going at 960 kilometers per hour. Indeed, a difference of 80 kilometers. And furthermore, if I multiply the first plane by 2 and the second plane by 3 halves, let's see what happens. So let's just check that. 2 times 880 plus 3 halves times 960. Let's see. This is supposed to add up to 3,200. Let's see if it does. Well, 2 times 880 is 1,760. And let's see. A half, that's 480. Oh, it's 1,440. I like that. And if I add that up, 1,440,001. That's a 2. Carry the 1. Look at that, 3,200. So there you go. And that again, this was what problem was this? What problem was this? This was number 66. So this is what I'm going to do right here, just for your reference. This was should have had this the whole time, but you saw it on that other screen. Number 66. Okay. Again, as I mentioned, I'm tending to do the even problems because you know. Anyway, the ones we can't find answers back. Anyway, this has been it's been a very big thrill, and I will see you guys next time.